Hi everyone, we're going to sketch the graph of this polynomial f of x. So the first thing we're going to do is to determine our degree. This is not in standard form, so I'm just going to take my multiplicities here and add them up. So I have 1 plus 1 plus 2 is 4, so my n is 4. That means we're going to discuss n behavior later, but just know that that's an even number. Also know that my lead coefficient here is negative. And we'll go back to this in a minute. All right, also our y-intercept, let's plug in 0 for all my x's. So that's just going to be, this is 1. 1 times 4 is 4. So my y-intercept is at 0, 4. Now my zeros are when y is 0. So this would be 1 here, negative 1, because negative 1 plus 1 is 0, and negative 2 here. So let's write those down. We have 1, 0, and negative 1, 0. Those have both multiplicities of 1, which is an an odd number. And this last one, this last 0, negative 2, 0, has a multiplicity of 2. Now, what you do on your multiplicities is you're looking at if it's even or odd. If it's odd, the graph crosses the intercept, and if it's even, it only can touch. And we'll go over that in a minute as well. Our maximum turning points is n minus 1, which is 4. And 4 minus 1 is 3. And we're going to determine the intervals where y is, the graph is negative and where the graph is positive by looking at the graph. So let's go back to our n behavior. And just remember our degree is 4, which is even, and our lead coefficient here is negative here. So even negative. Let's see. Even negative is right in here. In fact, our degree was 4, but it still resembles this graph. It resembles y equals negative x to the 4th, which looks a lot like this one. It's just that it's flatter in this area and it shoots down faster. But nevertheless, it still has the same shape. So we're starting in quadrant 3 when we graph, and we're going to end in quadrant 4. Okay, quadrant 3 is negative, negative, and quadrant 4 is positive, negative. So that's what this part's about. So let's look at that. As x gets larger and larger from 0, positive, our y gets smaller and smaller from 0, negative, positive. So there's your negative. That puts this area in quadrant 4. All right, from 0, as x gets smaller and smaller, so does my y. So you have negative, negative, and there's your negative, negative here. And this is what this is, positive, negative, negative, negative. So this is positive, negative is quadrant 4, and negative, negative here is quadrant 3. Okay, now let's graph this. We're going to start in quadrant 3, end in quadrant 4. Now, let's plot our zeros. We have 1 and negative 1, and also negative 2. Now, we start down here, and we go to negative 2. At negative 2, the multiplicity is 2. That means we can't cross the x-axis. So we're going to come back down. On these graphs, we're not going to worry about the min and max values. We just want a shape of the graph here. So we come back down and go back up to our negative 1. That's this piece. And it's an odd multiplicity here. So that means I can cross. Oh, and my y-intercept was 4. I forgot to plot that. 1, 2, 3, 4. So this is 4. This is negative 1 and 1. So go up to your y-intercept and come back down to 1. Now, 1, which was this piece, that also has an odd multiplicity. That means I can cross the x-axis. So we're down here. So it did satisfy our end behavior. We did it right. And now all we have to do is look at where our graph is above y equals 0 and where our graph is below y equals 0. So where f of x is positive is right in here, this portion here. And that's going to be from negative 1 to 1. All right, and down here, where is our f of x negative? We got 2 places. We have it right in here, all the way up into here. So that's negative infinity to negative 1. And here, let's do this one in red, from 1 down here. So that's from 1 to infinity. And that's it. Thank you. Have a nice day. Bye-bye.